equation was written based on, let's say if this was the sign convention for this equation, then if you have to put the values of, let's consider a case 1. Case 1 is, let's say, when delta B actual is 0. Let's consider some numerical values over here to make the things more easy to understand. Delta B actual is 0, and what else? So delta B actual, I'm going to represent this by simple VB, okay? VB 0 means the given, this B is fully restrained against displacement, okay? So VB is 0. And let's say W value for the first case is 30 kilonewton per meter, okay? In that case, and let's say L value is 6 meter and I value is 120 into 10 raised to the power 6 millimeter raised to the power 4, and E value is 200 gigapascal. Let's take some values to make it easy to imagine it, okay? So with these parameters given, so these are the constants for all cases we are going to discuss, but what I have written over here are the variables we are going to consider, okay? So in the first case, the VB is 0, so the given beam, so the actual is 0, actual displacement at B, and the W value is 30 kilonewton per meter, okay? So now this equation is applicable no matter what the case is, okay? So in this case, RB would be, or maybe we could start putting the values for delta B naught first, and then we can consider the cases maybe. Okay, so I could say RB is equal to delta B actual minus delta B naught. Now delta B naught is downward, and I had to choose a sign convention. If I take upward positive, upward displacement positive, keep in mind, okay, then I would say this is this minus is because of this equation. I mean, this is not a part of the displacement value. So I'm going to put the value of delta B naught along with an algebraic sign which accounts for its direction, okay, minus W L raised to the power 4 over 8 EI, okay, divided by delta BB, which is L cube over 3 EI. This is the equation. So I could simply, in the next step, if you allow me to do that, I could simply go like this, okay. So this is the expression in which you can put different values of delta B actual and the W value, okay, and you will keep getting different results for RB. So now let's discuss case 1. In first case, so case 1 is W equal to 30 kilonewton per meter and VB equal to 0. So support B is unyielding, so VB is 0 and W is 30 kilonewton per meter. So now you can start putting the values. RB would be delta B actual is 0, 0 minus, plus 30 times 6 raised to the power 4. No, you got to be careful with the units. If W is in kilonewton per meter, L is in meter, you have to have the EI in terms of kilonewtons and meters. Okay, so let's first write down the values for EI in kilonewton meter. Right now what we have is 200 gigapascal, which means this Newton per meter square, but we want to have it in kilonewton per meter square because our W is in kilonewton per meter, okay. Where is that W? This is in kilonewton per meter, so we got to be consistent. So is to make it in kilonewton, this should be 6. Okay, so I could say 10 to the power 6 kilonewton per meter square into I value. The I is 120 into 10 raised to the power 6. Now this is in millimeters? Yeah, millimeters. So we got to convert this to meters. How do you do that? Ten raised to the power 3 meter whole raised to the power 4. Oh, okay. Access. Okay, so we have converted millimeters to meters by invoking what? Milli की जगह हमने 10 raised to the power -3 लिख दिया, ठीक है? Meter raised to 4. So ये 10 raised to the power -12 बन जाएगा, meter raised to the power 4. So ये क्या बन जाएगा? If you simplify this, can you simplify this? ये 10 raised to the power -12 हो जाएगा, ये 10 over 6 है, तो ये 10 raised to the power -12. What should be the final units? This is meter raised to the power 4, this is meter square. So it should be kilonewton meter square. Okay? So, yeah, I'm sorry, over here. So this divided by 8 times 24,000 divided by 6 cube over 3 times 24,000, you can get your answer. So one way of doing it would be you just put the value of delta B actual and you can simplify the rest like this. WL raised, so it is equal to 0 plus WL raised to the power 4 over 8 EI divided by L. So L, okay, L cube over 3 EI. चल रही ठीक है कोई नहीं WL raised to the 4 over 8 EI. So you know what we can do over here? So it is 3 by 8 times WL RB. Now it sounds easier. You can just imagine what the value looks like. I mean in terms of W. Okay, so just put the value of W over here. W and L, 30 kilonewton per meter times 6 meters, okay, 135? 67.5 kilonewton, and it's a positive answer. I need your attention on this point. Positive answer over here means that what was assumed over here is the right direction. We assumed it upward. So a positive sign means it is actually upward. And you can imagine it should be upward because this is what you expect from the support, upward direction. So now RB is known. So RB is 67.5 kilonewton upward. So this is what we are talking about. If you can find one of the unknown reaction forces without using equilibrium equations, you can find these two using these two. Okay? Clear? So can you do that? Can you do that? फिर लग गया इसके साथ ये कुछ डिफरेंट लेवल्स पे लगनी चाहिए यहाँ पे चाहे कर थोड़ा इस तरीके से ऊपर इधर आप कनेक्टेड है इस प्लस साइन का मतलब है कि जो हमने यहाँ डायरेक्शन एज्यूम की थी वो ठीक है ठीक है ठीक है तो so now it's simple you have this beam 30 kilonewton per meter and this RB is 67.5 kilonewton. It is 6 meter long beam. Now you can find out the vertical reaction and the moment reaction over here. Okay. बताएं क्या वैल्यू होगी RA की? This L is 6 meters. So 180 minus 67.5. Okay. So you get 112.5 kilonewton. Or you can work in general values. If RB is given to you, you can find RA like this. WL is the load equivalent from the UDL minus 3 by 8 times WL. Okay. So 1 minus 3 by 8 for the WL. You will get 5 by 8 WL if you want to keep working in terms of W and L. Okay. It is important to be able to do this type of calculation because it gives you a sense of how the two reaction forces compare with each other. Okay. And what about this moment? Can you figure this out? Can you do this in terms of, can you please come back to the general values? W over here, L over here, this is, RB was 3 by 8 WL and RA is how much? 5 by 8 WL and MA would be, can you figure out? WL into L by 2 minus 3 by 8 WL times L. So it is WL square by 2 minus WL square 3 by 8 times WL square, WL square, sorry. So 1 over 2 minus 3 by 2. Can you do this? 1 over 2 minus 3 by 8, sorry, 3 by 8. So get WL square by 8. It is important to be able to write these results in general form. It gives you an idea. These are the results you may need in the next numericals, okay? So MA is WL square by 8. Of course, whatever the value of W and L are, you can easily put them over here and find the values, okay? Numerical values. So what do you think, which one is bigger? RA is bigger, and you can know this, I mean, what portion, I mean, how many times this RA is bigger, or how does it compare with RB? Okay? So whenever you see a beam like this, you should be able to guess that the reaction at A is going to be larger.